Thank you, Dr. Rossi. Thank you, the organizers of the meeting. I'm very glad to be back to Argentina today. I well remember my first stay here in Mar del Plata when I was talking about ALL in particular. Today's topic is our developments in MRD assessment in pediatric AML. And I'm bringing you our consensus approach of the IOP-BFM-FLOW network, which is a large part of the I-BFM-FLOW network, in which, again, many of you, and I have here the landscape, many of you in South America are also well-reputed part of this FLOW network. I'm speaking about harmonization and collaborative work in this network. A few years ago, we made a summary and overview of all the approaches of marker panels, because we in the IOP-BFM community were interested to set up this kind of consensus approach. And we found actually in the panels which were around, also including Euroflow, the Novo consortium in Europe, also the UK ways of assessment, St. Jude, and also BFM and IOP, that there was some similarity but also diversity of markers engaged. So we made a literature search and selected all those markers which are with the red dots to be used in something like a consensus approach. And plus, we were also looking over the pediatric limits, and also looking into what the European Leukemia Net of the Adult Working Party was using. And there is one of the most central publications on MRD marker panel coming from this ELN network, dating back to a blood communication from 2018. Mostly the markers also suggested in this panel are similar to those which were already known from the pediatric literature search. In this marker panel of the adult community, there is also a recommendation of the threshold of 0.1 as the threshold of most interests. Very recently, we have published on this marker panel where we also added some more innovative markers, which we have been researching in the last years on, which includes the marker CD371, CLL1 antigen, CD45RA antigen, CD99, and also CD11A as additional markers to the panels, as I have shown in the two slides before. So there are backbone markers, there are mandatory differentiation markers to be included. There are optional markers which can be leukemia specific as with a given leukemic case. And then there are the so-called innovative markers included. And this is a publication we have been done together with the Italian colleagues and representing BFM and IOP consortium. I would like to show you the marker setup, which we are now using since a few years already, which contains these markers based on a harmonized cocktail tube formulation. And we have now two 10-color tubes in place, which are similar done in Italy, in Germany, in Austria, in Poland, in Czech Republic, in Slovakia. So in the whole field of IOP-BFM. And this marker panel includes one tube, which we called leukemia-associated immunophenotype, which basically contains markers which are backbone throughout the two cocktail tubes. So you see CD34, 117, 33, 45, and HLA-DR. This backbone is very important to track all the cells of interest, myeloid cells, progenitor cells, all cells like CD45 positive through both of the tubes. And in addition, in the LIBE tube, there are further differentiation markers included, like CD15, 14, and 11B, essential differentiation markers of the myeloid and monocytic compartment. And then we have in the PE and in the APC channel, we have drop-in slots, open slots, where we can individualize, as I told you, based on the individual patient's profile, which we determine at diagnosis. This includes markers like CD7, CD56 as priority, but also CD99 and others. In the APC channel, we have markers like CD11A, 13, CLL1, which is the same, the CD371. The second tube is more oriented on progenitor cells. So this is why we called it CFU, colony forming unit tube. With this combination, we really have worked a lot on colony formation in leukemic cells, but also in normal progenitors. So this is why we call it CFU tube. It contains, again, the backbone, as I told you, CD34, 117, HLA-DR 45, 33, but also markers of interest for progenitor assessment like CD38, CD45RA, and CD123. In this tube, we usually add CD99 and CLL1, so that's the marker which also is known nowadays as CD371, a stem cell oriented marker. So this replenished is a tube which is oriented to investigate all profiles and differences of differentiating progenitors. So when it comes together, we are able with this tube to look into different differentiation of normal cells and see the operations of leukemic cells, and we can individualize based on the individual leukemia-associated phenotype. So it's a double check regarding the different from normal concept as well as the LIBE concept. But what is now needed to really do a good test on minimal residual disease in acute myeloid leukemia? Definitely in myeloid leukemia is more difficult even than in ALL, because leukemias are much more diverse and less, let's say, harmonized themselves as compared to ALL. So what we decided from the beginning, that actually we are going for a even more standardized laboratory procedures, for more standardized instruments, and for more standardization with cocktail tubes, not in that way, not single tubes, but dual tube approaches. But we are heading for pre-configured and even cocktail formulations. In that way, it is, you will see in a minute, it's not lyophilicized, but actually plastificized. So it's now the new technology, which is now available in reagents from Beckman Coulter, as well as from BD company. So let's start to speak about the standardization and harmonization process. You see, what does it include? I told you it's about SOP standardization, panel standardization, cytometer alignment, but definitely also about quality control. And we will speak today also briefly about operator independent analysis approaches. This procedure standardization has been already brought down to paper and also includes some of you of the from Argentina, from Jorge Rossi's lab, but also our colleagues even from Moscow as well as from Poland. Nowadays, we include also the group of Padua, which we are so sad to have lost Professor Basso during the course of the COVID epidemic and pandemia, and now is represented by Barbara Buldini, my close friend over many years. The tube I have shown you before is now available soon as a catalog product from Beckman Coulter. We are using it as a single batch production using the Duraclone production. So this we have produced something like 2,000 tubes for all our working group until now. And these Duraclone tubes are, as I have shown you, based on the marker combinations LIPE and CFU I have summarized before. We have given in this SOP on how to deal also a recommendation, which marker to use in the PE channel, which marker to use in the APC channel for the LIPE tube. As you have seen, we are including markers on the patient profile, as I told you, like CD2, 4, 7, 19, 56. For specific phenotypes like M6, M7 in particular, some of the M0s, marker CD11A in PE is one of our very interesting choices. And if there is no good choice from those, frequently CD99, CD4, or nowadays even CD48 is a good choice to be included in the PE channel. In the APC channel, we are running frequently CD13, but also CD99. As said, in the CFU tube, it's more or less a strict combination of CD371, the CLL marker nowadays mostly in PE, and CD99 in APC. Those two markers are those which we prefer throughout most cases because they define a very clear-cut separation of normal progenitor subsets, differentiating in different lineages already, still expressing CD34. So we don't individualize too much on this CFU tube. We prefer, as compared to the RLL approach, where we usually do a stain lyse procedure, with AML, we prefer a bulk lysis procedure because this allows us to insert in the prefabricated cocktail tubes very similar amounts of cells to both of the tubes in very limited value, which allows a very standardized staining in the cocktail tubes. This bulk lysis procedure is well adapted also from the large volume bulk lysis procedure, which has been recommended by the Euroflow consortium. We run the tubes already also at diagnosis because this allows us to define already how the initial phenotype would react with the cocktail formulation which we are using. But for the additional definition of markers, we use the broader panel of all markers, also the LIPE markers, which are included in our broader initial phenotyping panel. In follow-up, we use then both tubes, always both tubes, replenished with the drop-in markers as defined on the best choice of markers defined at diagnosis. We also developed, based on Calusa software, nowadays Calusa 2.1 software, predefined templates which are using Bayesian approach and hierarchical analysis of gating. And these protocols, you will see in a few minutes how that works. The overall gating strategy is based on first analysis of scatter properties, for the overview of time acquisition to see whether there are some changes in the flow through the droplet chambers. Then we look for and gate for singlets, and the exact denominator is actually a broad CD45 denominator, positive denominator window. So we don't have in these tubes this cytopositive applicability, because we rather prefer to assess cytopositivity in a so-called panoramic extra tube. But the most interest goes to the CD45 positive assessment. In some cases, like M7, we really have to be very wide open also to the negative area, to include also the blast, which sometimes are very dim and very low in CD45. And then we run denominators orientated on CD34 positive cells. With some of the leukemias, this is containing most of the leukemic cells of interest. But we also run more mature or CD34 negative compartment as well. And then we are interested to bring together the information for the whole MRD on both subsets. But what we don't do is actually, we don't do graphical merging of the separate tubes, but we record in which tube is the higher MRD value better defined. And this higher MRD value is the one which we use as the final MRD result. We have also defined the rules for interpretation of the acquisition analysis, which usually ends up with a higher amount of necessary events to be sure that this is a really MRD cluster, which is not like 10, which we use in easy to be defined ALL cases, but here we cluster about at least 50 events. We recognize the cluster as a percentage of CD45 positive events. We are interested, as I told you, in subsets of MRD events, either being positive with CD34 or negative. And we consider that MRD needs to fulfill at least two of the following criteria, which is unambiguous aberration from normal, fulfilling Leib criteria, and being a very immature cell. We know very well that sometimes maturation of leukemic cells, specifically in M2 with AML-ETO rearrangement, continues from very immature blastic cells until even granulocytic cells, or even on mast cells in 6-9, for example, translocated leukemia, you might find genetic signs of leukemia, but these are not the cells at this maturity stage, which usually can be enumerated and clearly defined as leukemia associated by flow cytometry. So flow cytometry is more based on the immature leukemia associated and initiating cells. And it will be very interesting to see in the future, when there are divergences between PCR results and flow cytometry results, which we very well know that this occurs, in those leukemias with differentiating cells, that what is more relevant, to see the immature cells or to see even differentiated cells for a prolonged time. And I remind you that specifically in 821 translocated leukemia, PCR positivity for a longer period does not really hallmark a bad sign of propensity to a relapse, but also can be just something which we have to accept, and only in case of a change or increase of such cells, it would be a hint for upcoming relapse. So in the same way, we think that the immature cells with the leukemia initiating phenotype are the most important, and this is well represented by flow MRD. As said, the panoramic tube we are using to build something like an end result of MRD per CD45 positive cells per cytopositive events. But what we give for the clinical assessment of MRD blast percentage, this is related to 45 positive, not to cyto. As said, again, this is a screenshot of such a Duraclone tube. In that way is a Duraclone CFU tube, where you see all the populations. This is a normal bone marrow, and you see all the populations nicely stained with the parameters included. This is, as said, this is 10 color stain, including also CD99 and CD371. And you also see the gating strategy, starting with the scatter plot, with the singlets, with a wide CD45 positive gate, exclusion of very strong CD123 plasmacytic dendritic cells, and then entering into CD34 positive compartment for further assessment. We can assess also numbers of mast cells, of plasma cells, and as a next step, this is what I told you about the CD34 positive subset analysis in the CFU tube. These cells you see here is only the CD34 positive compartment. This is a separation within the CD34 positive compartment of already differentiating progenitor cells into different lineages. And most importantly, we have the one plot which separates CD117 and CD33. The double negative cells are the lymphoid CD34 positive cells, while all the others go into the direction of myeloid cells or are even non-lymphoid earlier progenitors. And then the second most important plot I would like to draw your attention to is the plot where CD371, so the CLL1 antigen, and the CD45RA antigen are combined. And in this plot, what we call the so-called quadrant plot, actually you already see the separation of the most immature compartment where all the stem cell close progenitors are in, which is the double negative compartment. In this double negative compartment, you have either the CD38 lower cells, which are very stem cell close cells, also included the so-called MPP, so the myeloid oriented progenitors, very oriented multi-lineage progenitors, as well as already cells which go into the erythroid megakaryocytic progenitor compartment, the red ones, which also come from here in the double negative stage, but which are higher in CD38, lower in CD99. So this is actually a double population which comes out from here. Once you put those in methylcellulose, for example, you will find in the dark blue compartment, you will find clones out of single cell sorting going into triple differentiated clones. Either they can become erythroid cells, they can become monocytic cells, granulocytic cells, dendritic cells. So they have all the plenitude of differentiation potential, and you will get from single cells, you will get triple clones even of differentiating cells. So the more you go into what is light blue, this is the more you enter into single lineage monocytic cells, granulocytic cells, and those which are double positive, 45RA and 371. This is the so-called GMP granulocytic monocytic precursor. So very mature already before entering in promonocytes stage, before entering in promyelocytic stage. To the lower part, with 45RA positive, you already see that all the lymphoid progenitors are 45RA positive and CD30 371 negative. So this is this area here, and from here also, and I call it the GATA2 compartment. From here also come all the macrophages, the dendritic cells. So this is let's say the monomac GATA2 compartment, where if you have missing in a patient, in a non-leukemic patient, if you have missing this compartment, this is a strong hint that there is a problem with GATA2 differentiation factor, entering into having problems of B cell regeneration and production, as well as problems of monocytic production, monocytic dendritic macrophage production. So that's this area where these cells come from. So with this tube, CFU tube, you can build, and this is a pattern of normal bone marrow. This is not diseased bone marrow. You can build really on a very a detailed view of regeneration and activity in the progenitor CD34 positive progenitor compartment. And once you look into a leukemic case, you will see there is restriction in these patterns. And you can use this restriction of patterns within this tube also to analyze a regenerative bone marrow for leukemic cells. And you see here a regenerative bone marrow where you have the so-called normal progenitors very nicely separated also into this tube. But you see how they also differentiate into different CD34 normal cell types. But then you see that leukemic cells not infrequently are different from those normal precursors by aberrant expression of some of the markers. And this is the marker spectrum I called innovative marker spectrum. So for example, this case very clearly is separating by overexpression of CD45RA or underexpression of those 45RA expressing cells of the CLL CD371 marker expression, or overexpression of CD34. So based on this panel, you see that you can also differentiate leukemic cells in the 34 positive compartment based on aberrant expression patterns by leukemic cells. Let me speak about cytometer alignment. What have we done? We have started to build in Vienna on usually we have now this DX Flex machine. In former times we have Navios machine. And we did the panel definition. We created target MFI values, exported those target MFI values to Padua, Essen, and the other colleagues, and then made the machine setup at the other location, the other DXFlex machine with similar setup for the target MFIs. And this portability is well known to many of you, I think, also from the ways also Euroflow has been exercising with their approach. And by this way, we are now running in the ability that, for example, as you can see, this is overlay plots of sample exchange. We stained samples in Vienna, sent them to Padua, sent them to Essen, and we're running after this first machine setup, standardized setup, to prove that the samples would look like the same. And you see also throughout all the channels that with very few differences, the machine setups are very, very homogeneous between centers. Also, if you overlay the samples acquired in Vienna and Padua, the overlays are very, very similar when we do record them from the two centers. Also, the scatter properties are very similar in setup nowadays. And also with the other tube, the first was Leib tube, CFU tube, very similar setup which we could record. So, and once you go into leukemic cases, how would you see them? This is, for example, a Leib tube which was tested on the same patient, which was sent to Padua and to Vienna. And there you can compare from the left to the right the same patient seen with the different machines at the different places. And honestly, without knowing where is what from, you would have really your problems to say that this sample was done in Padua or this sample was done in Vienna. All in all, you see that, for example, this case had some strange features which were overexpressing CD99, negativity of CD11A, negative differentiation markers, negative HLA-DR, low CD45 expression, low CD33 expression. So several features which are very unusual for any normal cell, and by that way could well be trapped by the MRD tubes. This is the other tube, the CFU tube. Also in this, you will find very similar staining from Padua and Vienna. And you also can see that there are some aberration phenotypes like CD38 negativity, which we can find also as a new marker of interest in this tube. But you see that the other markers which were also in the Leib tube, like the standard marker panel 34, 117, 45, 33, HLA-DR, it's very similar. So we see the same cells as leukemic cells. At the end, what came out in Padua was 0.67 MRD. In Vienna, it was 0.66. We lumped together blasts from the CD34 compartment and from the CD34 non-positive compartment, and they are brought together to build the final MRD positivity. Here you have the time flight, so we control on this, and you see that it was a very homogeneous acquisition over time, so no bubble included, etc. Another case here, for example, once we only look at the most important marker combinations with the innovative markers CD99 and 11A-PE, very nicely distinguished, very similar between the two labs. Also, when we lowered the amount of cells. So these were spike-ins into a normal regenerating sample of bone marrow. You can see that there was, with the spike-in target of 0.1%, the output was very, very close in both centers around this value. So this was only intended, not tested, intended 0.1 of spiking. And once we go to Essen with the same sample, not the same sending, so we redid this sample another day and sent to Essen, and you also see also the 0.1 is very nicely, so this was another spike in, so maybe not as good as the one before, but again, we brought out similar percentage found in Essen and Vienna, again, very nicely separated. And also this is the higher MRD amount, very nice separation by the markers, very similar between Essen and Vienna. So to summarize, it is possible to really standardize AML MRD throughout a network of laboratories. And now we are thinking about how to control ourselves in the future. Either we can control with PCR values. We did an exercise nowadays with already something like 50 cases tested in Vienna on these dual tubes, tested with MRD based on DNA, not RNA based PCR MRD, and you see how nicely we can follow leukemia based on the two methodologies, with the one drawback: the flow cytometry is available from the beginning. From the first day, we are able to have this set on. And while we need to develop the PCR targets, the markers, until we know the genetics, until we know which exact breakpoint is there, until we really can follow the leukemia, sometimes it takes 2 months. So it's too late usually for an early response assessment and early stratification. So the method of choice in nowadays European protocols is definitely flow cytometry, because of the speed of early response, the capability of response assessment. By doing this also, we can see that in the range of interest, so we would say until 0.1, so that's the limit of interest for the protocols nowadays used in Europe, is either being at 1% after first induction, or at 0.1% after second induction. Is of interest in IOBFM protocols, and in this range, flow cytometry is very, very similar to PCR, while we recognize that in the low quantitation of low-level MRD quantitation, flow cytometry usually has limitations, while DNR PCR can peak leukemias even lower than 10⁻⁴, so lower than 0.01. This is definitely with flow cytometry not feasible and won't be feasible for each and every patient in the future, but on the other hand is also not feasible for each and every patient by PCR, because not each and every patient by PCR has a targetable fusion transcript, fusion breakpoint. So all in all, both methodologies also in later times of assessment have their place. We also run now UK NECWAS round robin tests. You know, many of you know very well that this exists for ALL, but we also can use that for AML nowadays. It's not accredited yet, is a pilot phase. But nowadays already quite a lot of samples 4 times a year can be assessed also for AML MRD. And you see, we also can investigate through individual centers' performance through this approach with the Neckars tubes. And we hope very soon to send out the first list mode data round robin tests. This is an example from list mode data from ILL send arounds, and many of you know this approach, and soon we will also do that for AML MRD. And you know, for ALL, it really helped to improve. You see that, for example, when we look at all the contributing I-BFM labs, which started in ALL ring trials, list mode data ring trials, there were a series of 8 centers which had of critical insufficient assessment quality in the first ring trial, and there were 0 in the last 2020 ring trial out of a group of 41 labs in our I-BFM consortium. So this is highly statistically significant that by doing this kind of tests and by having educational rounds, it's feasible to educate labs which are not yet at the stage of high quality assessment in MRD. And we hope that also in AML MRD over the next few years, we will be able to develop quality in the total of our consortium, or at least those centers now entering the trial groups for AML assessment. And to end with the automated project, it's not only for lymphoblastic leukemia, where we have improved, and nowadays it already works very well for ALL. And we even improved over the years since 2016 to 2019 to have very high F scores. So F scores are the most important. Is not like are we concordant in the percentage of wells, sondern are we concordant in the exact events which have been picked. So because sometimes you might have the similar percentage, but even mean different cells. Although this is a rare occasion, the F score really tells you is it not only the exact percentage, but also really the same cells which you have picked by the 2 methodologies. So the F score, once it's above or around 80 to 90%, this means this is something like a fully available methodology for the clinical practice. So nowadays we would think that we are already there at an MRD level of 0.05, which has an acceptable quality with the automated methodology in ALL, but still we have to do some work to end up at similar quality also with AML. And we really hope that this will improve the complexity which is really there in AML. And we are running a large project now in Europe, which is calling MyFlow, which is devoted to AML MRD automation analysis. So with this, I would like to acknowledge all the partners in the project, either being the I-BFM-FLOW major partners contributing to our work, also including the AML MRD work, but also our technical people with the algorithms out there from the Technical University in Vienna and other locations. And I would also like to acknowledge Beckman Coulter and XPO company for their help with developing the Duraclone tube, cocktail tube formulations. They really were of help and assist us also with defining the best combinations. but they never introduced any pressure on us how to develop the methodology and how to do the academic research. So with that, I would like to thank you, and I'm happy to take your questions. Thank you very much.